Good morning, everyone. Welcome to today's webinar for British Science Week. We are expecting quite a lot of people to join us today, so we will wait a few moments before we get started. But whilst you are waiting, you could have a look at the picture that is in my virtual background. So have a little think, what can you see in this picture behind me? Do you know what these objects are called? Have you seen one before? And do you know what they do? So have a little think. You could type the answer into the chat or the Q&A if you wish, and we will get started in a few moments' time. Hello to everyone just joining us now. Welcome to today's webinar for British Science Week. We are just going to wait a few more moments to get started. But if you want to have a little think whilst you're waiting, what can you see in my virtual background picture? I'm seeing some answers in the chat already, and I will give you the correct answer in a moment. Okay, I think we have most people with us now, so let's get started. Good morning, everyone. Welcome to today's webinar for British Science Week, and we will be talking all about careers and jobs in the space industry, and we will be showing you some exciting space projects that you might not have heard of before. My name is Vicky and I will be hosting the webinar today, and I work for RalSpace. We are the UK's National Space Laboratory. And to give you the answer, these two objects behind me are two of our antenna or dishes, satellite dishes. So well done if you got that correct. I did see some correct answers in the chat. So we use these dishes to help track satellites. So you might have a smaller version of these stuck onto the outside of your house that picks up TV signals. So these ones are much bigger. They're about 5 or 6 meters across, and these pick up satellite signals from satellites that are orbiting around Earth at the moment. And we can use these signals to track the satellites or to gather data and information, things such as pictures taken from satellites looking down over Earth. So just before I talk a little bit more about RalSpace, who we are and what we do, and introduce our speakers, I'd like to find out a little bit more about you. So to see if you are awake this morning, I'd like to launch a quick poll. Do you agree that space is for everyone? And the third question, would you like to work in the space industry? So interested to see what you think. If you're in a classroom, you could put your hands up and give us an average idea of what you think. So I'll give you a moment to answer those questions. We have people joining us today from all across the UK, which is wonderful. We have schools registered from London, from Manchester, from Glasgow, Birmingham, and Cornwall. So welcome to everyone today. Okay, so I think I am now going to share a little bit more about RalSpace and show you what we do. This is the front of one of our buildings. As I mentioned, we are the UK's National Space Laboratory, and we help to build and test spacecraft. So we are based just south of Oxford in England, but we also work with teams in Daresbury in Cheshire in the northwest of England, and also the Royal Observatory Edinburgh in Scotland as well. And we often work on big space missions with ESA, the European Space Agency, and NASA in America as well, who you might have heard of. So we've been involved in over 200 space missions over the last 50 years. One of the big ones that's coming up later this year that you could look out for is we are hoping to see the launch of the Webb telescope. This is the James Webb Space Telescope, which we have been involved in, and that will be taking some amazing pictures of galaxies and stars and things. So that's due to launch on Halloween this year. This is the front of one of our buildings. This is where my office normally is. And inside this building, we have lots of facilities and tools to help build spacecraft. So we have special labs called clean rooms, and you can see in the picture that we have people wearing special suits to keep everything clean, and you'll hear more about that in a moment. So once we've helped to build part of a spacecraft, we then need to test it, because if we then send something up into space and it breaks, it's not easy to go up there and fix it. So we make sure to test it on ground first. And you also might know that space is a vacuum. There's no air. So what we do is we use big vacuum chambers. We put our spacecraft inside this chamber, we close the door, and then we suck all of the air out to make a vacuum. We turn the spacecraft on to make sure that it works as if it were in the vacuum of space. So once we've checked that it works correctly, we send it off to someone else to launch on a rocket into space, and then it can start collecting data, and this could be some pictures of the Earth or pictures of the solar system, for example. So we then help to collect all of that information and we store it on a big supercomputer called Jasmine. And Jasmine can store about 45 petabytes of data. So just to give you an idea of what that is, a typical smartphone these days has about 64 gigabytes of data. So Jasmine would be the equivalent of 700,000 of those smartphones. So, as well as our scientists and engineers and technicians, we have people who work in astronomy, who work on solar physics, looking at the sun, Earth observation, climate and weather, and people who are helping to develop and make new technologies, working with electronics, lasers, making cameras for space, and much, much more. So, we currently have about 300 people working for Railspace, and that includes graduates, people who have just finished university, some apprentices who have just finished school or college, and also some work experience students as well. So at the end, we will be sharing a list of links where you can find out more information about these different types of jobs and some experience that you could get in the future when you're a little bit older to work in the space industry, which is very exciting. Okay, so let's get on to the exciting part of today. I'd like to introduce our speakers for today from Space. We will have 3 people talking about their jobs, sharing their stories of what they do and how they got into the space industry. And then we will hear from the National Space Academy as well. And do remember to send in your questions as well. So our first speaker is Catherine from Space. So when you are ready, over to you, Catherine.
My name's Catherine and I'm a spacecraft thermal engineer at Ralspace. And first off, I'll tell you how I ended up working in the space industry. So I was lucky enough to have a grandfather who lived in Florida, and I grew up watching launches from Kennedy Space Center, which is a great privilege. So you can see in this picture here, tiny me with a space shuttle. And then from there, I continued to also enjoy doing maths and sciences at school. So I continued that through A levels, did maths, further maths, physics and history. And the maths, further maths and physics maybe make sense to you as things for engineers to do. But actually the history has also been useful because it's given me the skills to be able to write reports and understand how to communicate with people better, which I think are also very important skills to have as an engineer, as a sort of side aspect. And then from having done these A levels, I decided that I wanted to continue looking into aircraft, into spacecraft and things like that. So I went off to Bristol University to study aerospace engineering, which was mostly a course based in aeroplanes. So I spent lots of time looking into how to design aeroplanes to take people on holiday. And then as I got towards the end of my degree, I then got to choose what area to specialize in. So we could specialize in aeroplanes or helicopters or space. And my choice was space because from an early age, I'd always been inspired by the space industry. And I knew that was the route I wanted to take my career in. So I also took lots of opportunities to learn about the space industry, both when I was at school and when I was at university. And I'd really recommend, as you get towards starting to think about career choices, having a look around to see what courses are available. Lots of these courses are fully funded either by the UK Space Agency, European Space Agency, and things like that, and give you an opportunity to find out if it's a career for you. So the first one I went on was European Space Camp, which is for people 17 to 20 years old. And it gave me an opportunity to meet people from lots of European countries who are interested in the same things that I was in, and get involved with working towards a rocket launch and understanding the physics linked to that rocket launch. And then the second course was a human spaceflight course where I got to go to the Arctic Circle and meet astronauts and learn about how humans are healthy in space and how the lack of gravity affects humans and things like that, which are associated with sending people to the International Space Station or sending them to Mars or the Moon in the future. And then finally, I went on a summer school called Altbach, where it gets a lot of students together, both engineering and scientists, and then you have to design a mission, which is a really exciting thing and felt a bit like working in the space industry does now, because it's a really big team effort, bringing together lots of different people to try and achieve, to learn lots of things from the mission and make it worthwhile to do. So at university, I, as I said, had specialized into space. And as my final year project, I had to choose an area of interest, which for me was thermal engineering. So my project was trying to design a solar shield. So this is if a spacecraft is going towards the sun's really, really hot, 500 degrees, something like that. And to stop the spacecraft from melting and allow the instruments to work behind it and still produce this great science, you have to have something in front of the spacecraft to protect it from that heat. So as my final year project, I looked into the different materials that are available in order to produce this kind of thermal shield and protect the spacecraft. And then from there, I went on to the STFC graduate scheme as a thermal engineer. And I've been working here ever since, working on mainly Earth observation missions, which produce weather data and climate change data and things like that. So as a quick overview of what I do as a thermal engineer, we have to make sure that the fragile parts inside a spacecraft aren't going to be damaged by the harsh temperatures of space. So as two examples here, on the top picture, we have the Solar Orbiter spacecraft, and that one's going really close to the sun. And as I said before, it's really, really hot close to the sun. So that's the hot extreme of what we deal with. And then Vicky mentioned the James Webb Space Telescope. And that telescope is looking out into deep space, and it's looking for tiny amounts of heat really, really far away. So the spacecraft itself has to be really, really cold. And whilst we're thinking about all of that, even fancy space electronics only work at around room temperature. So we have to deal with those two different extremes of temperature. And then once we've designed and built the instrument, we have to test it in one of those big vacuum chambers that Vicky showed in order to check that it's still working. So as a thermal engineer, we have to think particularly about the three different ways that heat is transferred. So the first of these is radiation. This is like if you stand in the sun on a sunny day, you feel warm, and that's radiation. And then we have conduction, which is heat moving through a material. So if you get a bit of material and you put it in your tea, eventually the heat will work its way through that material up to the end that you're holding. And then finally, we have convection, which is the movement of liquids or gases. And this one doesn't really affect us in the space industry because we don't have to deal with air, which makes our lives easier in some respects. So now I'm going to tell you about a project that I've been working on, and it might not be immediately obvious how this links to the space industry, but hopefully I'll prove how spacecraft engineers can make a difference in areas that aren't just obviously space. So a big issue in India is that 40% of fruit and vegetables they grow go to waste. And this is a big problem for many reasons. First off, if these farmers are putting time and money into growing the crops, growing all these nice tomatoes and things, and if they're being wasted, then that's going to lead to the farmers not having any money because when they come to sell their crops, they're not getting any money back from them. And then it also causes greenhouse gas emissions. So climate change is in part caused by this, and the rotting vegetables lead to these emissions, which can impact climate change. And finally, it's really important for everyone to have good food available to them, lots of fruit and vegetables to keep them healthy. And if 40% of the fruit and vegetables are rotting, then that's going to affect the things that people have available. So what the project hopes to do about it is, first off, we want to understand the problem. So we have 50,000 farmers giving us information about how they grow their vegetables and how their vegetables move from their farms. They're transported on trucks all the way to the markets in the big cities. And then they're sold in these markets and make their way into people's homes and onto their plates. And we want to understand how that happens. And then the different way in which we store the fruit and vegetables makes a difference to how well they're kept and whether they're likely to rot. So if we find better materials that keep them healthier and happier, then that'll be better for the vegetables long term, and the farmers will be able to get more money when they go to sell them. And finally, we want to make sure that any of these solutions are accessible, which means that we don't want to bring in a really expensive solution that people in India won't be able to actually afford. So we want to find materials that people are already using in India, but maybe not using them in the way we'd choose to use them, and trying to help them find the best materials for the job that they can afford. So how does this link to thermal engineering? As I said before, we have to deal with really, really hot and really, really cold. And in India is incredibly hot. It's not quite to the 500 degrees, but in the summer there it can be 40 or 50 degrees. So it's really challenging to protect these fruit and vegetables from the sun. And as thermal engineers, we understand how different materials act differently when the sun is heating them, and whether they store that heat and give that heat away. So by understanding that in the materials, we took a load of samples from India, as you can see this bottom left photo. And by measuring these samples, we can work out what the best solution is. And then hopefully we can make a difference in the long term to the lives of farmers in India and help them to get more money for their vegetables. And if you have any questions, I'd be happy to take them at the end.
Thank you very much, Catherine. I thought that was really useful and interesting to see how you can help solve problems with these sort of ideas from space and from engineering and use it to help communities across the whole world. That's incredible. And uses different skills as well. So not just engineering and science, but maybe communication skills are really important as well. Okay, so if you do have any questions, make sure to type them into the Q&A and we will come back to them at the end. Our next speaker is Angela, who is a technician for ralspace. So when you are ready, over to you, Angela.
Hi everybody, my name's Angela and I work at ralspace in Oxfordshire as an MLI technician. Now, some of you might know that MLI stands for multi-layer insulation, and basically this is a shiny material that looks like tinfoil that you see when you look at the picture of a satellite in space, or here as you can see in the slide. Everything that goes into space will have some MLI on it. It's really important as it helps to keep the delicate equipment inside the satellite at a temperature where it can keep working, so it stops things from getting too hot or too cold. We call the individual pieces of MLI blankets, which leads me to the strange way that I came to be doing this job. When I went to school, I really liked science, but I really wanted to do something medical. So I did A-levels in biology, chemistry and physics, but I wasn't too hot on the maths. I ended up being a radiographer. And if any of you have ever had an X-ray, then the person that did the X-ray was called the radiographer. So I liked and was interested in equipment and machines that did different things. So time ticked on and I stopped doing that and started making crafts and had a couple of children and did that for about 10 years. But I was looking for something a little bit more adventurous, let's say. So I saw an advert for an MLI technician at ralspace. So I was intrigued because why would a space company need MLI blankets? So I used Google and Wikipedia to find out what it was all about. And it sounded like something I would enjoy and it sounded exciting. So I applied and I got the job. That was 4 years ago. So what's life like in a day of the MLI technician? We make the blankets in a clean room. So you can probably guess from that name that the room is very clean, and you'd be correct. The dirtiest thing in there are human beings. We bring in dirt from outside and our skin is constantly shedding cells. So when we work in the clean room, we wear a special uniform. We start off with a cap to cover our hair. You might have seen people wearing these at the deli counter in the supermarket. Then we put on a mask which protects the materials from the tiny droplets of water in our breath, or if we cough or sneeze. We put on plastic shoes over our own shoes, and then we put on a suit which is a bit like a onesie. And finally, we put on a pair of overboots. So that sounds a little bit hot, doesn't it? Actually, it's not too bad because the room is kept at a constant temperature and humidity. So on a hot day, when it's hot outside, it's pretty cool in the clean room. And on a cool day, it's relatively warm. So each blanket is made up of about 10 layers of the shiny foil material, which is actually a really, really thin layer of plastic coated in metal. It's usually aluminium. So you've got 10 layers of the foil separated by 10 layers of a netting material. The foil is really, really thin and it's very delicate and it's also very expensive. So it's really important to be careful and not to tear it. So if any of you have ever been to, say, a wedding or perhaps been fishing, the netting is a bit like the material used for the veil or the fishing net. This is put in between the layers of foil and this helps stop the heat transferring from one layer to the next. And also the mesh is really light, which is important because we want to keep the blankets as light as we can. So we have patterns to show us what shape to cut the material to. We can make all sorts of shapes depending on what the blanket has to cover on the spacecraft. And if the blanket has to go around a camera, we can leave a hole so that the camera can poke through. We've also got to be very precise when we're making the blankets, A, as they need to fit exactly, and B, as you can see in the slide, we use scalpels. So you've got to keep your fingers intact as well. So on this slide, you can see the holes in the blanket for the equipment to go through. The side that you can see here is the side of the blankets that's going to go against the satellite. And in the next slide, you can see the blanket that, as you would see it from if you were looking at the satellite. And again, you can see all the holes and cutouts that go around the pieces of equipment. So once the blanket's finished, we've got to weigh it because it's really important that the engineers know how much the satellite weighs altogether before it's launched so that they know how much fuel will be needed to get it into space. So on the next slide, we can see how we attach the blankets to the spacecraft. So we call these, if you can see the little gold things, we call these studs. Basically, it's a disc that we glue to the spacecraft with a projection that sticks up. And what we do is we punch a hole in the blanket, fit it over the stud, and then put a little clip on to stop it coming off the satellite or whatever it's on. Although we did hear of an astronomer who spotted what he thought was a UFO, but it turned out to be a piece of MLI that was sort of floating in outer space that had actually come off the satellite. But whether that's true or not, I'm not sure. While we've been working here, I've been to Germany and to Turkey to put blankets on satellites. But there are lots of places in the UK that build satellites, and so a lot of work is done here too. And it's not just satellites, it's sort of things that support the building and the launch of the satellites. And it's a brilliant job. And if you go into your garden in the evening and to look up into space and think that something you've made is orbiting the Earth, it's really quite an exciting feeling. So recently we had some blankets that went up on the solar orbiter. That was the beginning of the year. And my story shows, I think, that you don't have to be a scientist to be part of the team that puts things in space. It's a great team of people made up of engineers, scientists, technicians, all sorts of people. So if you follow your dreams, keep learning, and take every opportunity that comes your way, then literally the sky's the limit. So I hope that you've learned a little bit more about MLI and a little bit more about the people that make them. And so can I hand back to Vicky?
Wonderful. Thank you so much, Angela. That was an amazing talk and really interesting to see actually that you don't always need to do science or maths in order to be part of the space industry, and that actually creative skills are so important as well. Something that you could make with your own hands could go into space. So that's a great message for today. Thank you very much, Angela. If you do have any questions for Angela about what she does or about her route into space, do type them into the Q&A box. And we will now move on to our third speaker, Mario, who is a space weather scientist for ralspacee. When you're ready, over to you, Mario.
Thank you, Vicky, and welcome everyone. For those of you that are seeing my virtual background, maybe you can put in the chat what do you think it might be. It's definitely related to space weather, and I'll come back and tell you at the end of the talk. So first of all, I have a small poll for you to start filling in as I start to talk here. So I'm the head of space weather at ralspacee. I have a varied role. I'm not just a scientist. I do lots of interaction with government types, with policymakers, with lots of technicians, industry types. It's a very varied role. It's not just pure science. A lot of activity, and I can see that there's lots of action coming in on the poll. I'm going to end it in about 10 seconds time. And here you can see on the cover that I have some initial pictures showing various aspects of space weather. And for my talk, I'm going to actually tell you a little bit about space weather first, and then I'm going to tell you how I got there at the end. So I'm just going to end the poll so I can move it out of my way. Thank you all for filling it in. Okay. So space weather is a natural risk. And the reason it's a natural risk is for the same reason that flooding, tsunamis, and volcanoes are natural risks. These are things that are usually near floodplains or on floodplains and near coasts, and also things that can be near volcanoes. So you might think, well, why is space weather also a natural risk? Well, space weather is a natural risk because we live on a planet that is near a star, and that star gives us all of our life and all of the energy that powers the environment, but it's also a risk for us, and it's something we need to look at and need to consider. So all natural risks occur in places that are really good to live, but they are occasionally hazardous, and we just need to learn about it and understand it, and occasionally we can try to forecast it. Just like we forecast the weather on Earth, we can try to forecast the weather in space. So here I'm going to show you just a little demonstration of everything you can see from the sun coming through the bit between the sun and the Earth, which we call the heliosphere. And then as the material and the energy comes down, it hits our magnetic bubble, our shield. And this shield protects us from most space weather, but some of the energy and some of the particles can hit that shield, and they travel down our magnetic field lines, and they can enter parts of the hemisphere at the northern and southern parts of the sky. And my virtual background is actually one of the results of space weather. It's one of the beautiful results of space weather, and it's called the aurora. And if you go up far north or down far south, and at times of active space weather, you might be lucky enough to see it for yourselves. But it's all about this exciting flow of energy that comes from the sun, travels through the interplanetary medium of the heliosphere, and ends up interacting with our Earth. But it does have some other issues too. But before I get onto that, I just wanted to show a picture here of the Met Office Space Weather Forecast Center. And as you can see, it's quite an interactive environment. They have many, many screens, many, many models, and many, many data sets. And you can here maybe see a little bit about the complexity of space weather in terms of how you understand it, and indeed how you forecast it using models. So space weather, believe it or not, can affect your everyday life. So just when you think that, you can turn the electricity on, you can have a phone call, you can jump on the train, you can go on a plane or a boat, all of these rely on various power and communication devices that can be affected by space weather effects. So by forecasting space weather effects, we can understand better how it might have an interaction or an effect on something we rely upon. But it also enables us to learn a little bit more about how strong these effects are and how we might be able to mitigate against them in terms of being able to maybe come up with engineering solutions. So here you can just see some examples. In the bottom left-hand corner, you have farming. There's certain parts in the world, particularly in Brazil, where they actually rely on our satellites to tell them exactly where they are in the field and exactly how much fertilizer to put down, or where to plow, or where to put seeds. In the top here, you can see aircraft. Aircraft are reliant on space weather effects on their navigation systems and their communication systems. And the more we learn, the better it is we can understand it, and the better it is we can forecast it, and therefore mitigate against some of the effects. So just a little brief spotlight to some of my research. One of the projects I'm involved in at the moment is to transform a radio telescope into basically two separate telescopes with very little change in terms of its infrastructure. And that will enable us to look at all aspects of space weather. So the fun and exciting stuff close to the sun, the exciting stuff as it travels through the interplanetary medium in the heliosphere, and then how it interacts with the Earth, and of course causes this lovely aurora behind me. And here on the right-hand side is what we call a 3D tomographic reconstruction, or a CAT scan, similar to if you have a CAT scan at the hospital where a sensor rotates around your head. We're using radio telescopes on the Earth to point into lots of different directions, and the material passes over our sensor. So therefore, we can then build up a picture of what's happening in space and what's coming towards the Earth. So how did I get here? And what do I do on my daily basis? So it might surprise you to think of me at a computer doing lots of complicated and arduous tasks, but it's actually not that much so. A lot of my tasks revolve around reading, writing, speaking, and numeracy. They are very key to everyday work and everyday tasks that I undertake, both in science and in interaction with other people. Then I also do a little bit of programming, and then a lot of negotiating and influencing. And part of this is to deal with policymakers, with other scientists, with team members, with leading my team, and also in terms of trying to get more funding for the future. So these are all really great key skills, but they all stem from reading, writing, speaking, and numeracy. Without those, pretty much the programming, negotiating, and influencing just won't happen and won't work. So I started off in primary school in the Welsh Valleys. I went then to a comprehensive school 11 miles away, where it was there basically that set me on my path for my career. It was my A-level physics teacher. He really inspired me. Without this influence, I wouldn't be where I am today. And the A-levels I undertook were physics, chemistry, mathematics, and I also did AS level music. And it was that AS level music really gave me the nice balance between the sciences and the arts, and that distraction when science got a little bit too intense and I needed some time out, I went and did some music. Then I went on to London. I lasted all of about 7 weeks in London because I really didn't like the environment there. So I moved back to Cardiff, where I completed my undergraduate in physics with astronomy. And then it was from there that's really discussing with various people of where to go, and remembering the influence that my science teacher had on me, that I really wanted to go and do a PhD in physics. I then went to Aberystwyth University. From there that I did my PhD. And then I moved then to San Diego in California. I spent 3.5 to 4 years there before moving back to Aberystwyth for a few years, and then eventually ended up in ralspace, where I started off as a space weather scientist there, and now I'm the head of space weather. So basically, all of this has led me to be able to do some great, exciting science. I've met really, really great colleagues. I've been influenced by great colleagues the world over. I've been able to mentor people. I've had PhD students of my own. I've had postdoctoral researchers of my own. And I've interacted great with primary school children in terms of mini projects. And I've been able to get this job through my career path, through the A-levels, through communications, through those core skills of reading, writing, numeracy. And also it's undertaking this groundbreaking research, which is really exciting, and understanding how space weather can affect society and us and everyday items. I've got fantastic colleagues all over the world. We interact now on Zoom. It used to be that we'd see each other maybe 2-3 times a year at conferences. But the last year during the pandemic, a lot of this has moved online. So we have a different way of working. But we actually publish papers, we write book chapters, we organize conferences ourselves. And I've been able to present all around the world, including at the United Nations. And here you can see the United Nations room, the plenary room in Vienna, where a couple of years ago, I was very lucky to be able to give a presentation to the UN representatives at the Science and Technology Subcommittee of UN COPIUS. And with that, hopefully I've given you some interest in space weather. Hopefully I've kind of inspired some of you. Maybe you will look to your teachers for inspiration the same as I did. And I'm going to hand back over to Vicky. Thank you, everyone.
Thank you so much, Mario. That was amazing and really interesting to see where doing science at school has taken you in your future and who your role models were as well. So lots to think about. If you do have any questions for Mario, do type them into the Q&A box and we will come back to them at the end. Okay, so I'm now really pleased to introduce Kieran, who is the manager of the National Space Academy, and she's going to talk to you about the support that they can provide schools and how they help lots of you, more young people, learn about space and jobs in space as well. So when you're ready, over to you, Kieran.
Hello, thanks Vicky, and hello everybody. This is kind of what we aim to do, a bit of inspiration for the next generation, kind of what Vicky and her colleagues are doing here today as well. And how do we do this? So we're the National Space Academy, but we're not a location. So it's not like a school location, like an academy in that sense. But what we do is we do a lot of programs for young people and for teachers that use space science to bring classroom science to life. So student masterclasses are the first way we do that. Got a few pictures here of a few different masterclasses that we've done. Most of the time, my team aim to work with secondary level students all the way up to further education levels, so up into A-level or equivalent. And all the time we're trying to do things that are hands-on and engaging so that you really get the hang of what the science is. So for example, you can see two students in the middle picture there with plungers. What they've been looking at is investigating how a vacuum works. So putting those two together, you can create a vacuum and it's very hard to pull apart. So we like to set challenges like that. And we do this for all of the sciences and maths. And all of our programs are delivered by subject specialist science teachers. So for any teachers watching thinking, wow, that sounds really interesting, I'd like to do that kind of thing in my classroom, we also do teacher CPD. In the top left-hand picture there, you can see the team of teachers who work with us directly, the lead educators, at Newton's Apple Tree, not too far north of where I'm based, which I'll talk about in a minute, and a few other pictures of some of the training that we've done. And we also have written educational resources. So you can see a picture of a badge and a coin there. That's the Astro Academy Principia project, which we worked on with the UK Space Agency and Tim Peake. And the Astro Academy Principia resources are freely available. If you search Astro Academy Principia, you can find the website, and also on the National Space Academy YouTube channel, all the videos that Tim Peake filmed for us for that are freely available for teachers to use. So yes, happy to work with teachers who might be watching. For young people who might be watching thinking, well, is there anything the National Space Academy can offer me? Well, if you're interested in a masterclass, we normally get your teachers to book and we book through schools rather than individuals. But we do offer a course. It's a 2-year full-time course for young people. It's a post-16 course, so it's for young people who finished their GCSEs or equivalent. And it comprises of 2 A-levels, maths and physics. And we've been hearing this morning how important maths and physics can be if you enjoy those subjects. And it's combined with a BTEC level 3 in engineering, which is a 2 A-level equivalent. So it's a lot of work, but it allows you to do some hands-on engineering work and to work on a project, an engineering project as well. And I've got some pictures here from the space engineering course. We co-deliver it with Loughborough College. Loughborough College do have accommodation on site for under 18s because they do train young people. So if you are interested in coming to study on this course, you don't have to live in the Loughborough and Leicester area. We have had students come from all over the country. A few pictures that I'll highlight here. You can see our space engineers are wearing their space engineering shirts. The top right-hand photo in the middle in the jumpsuit is an astronaut called Chris Hadfield. He came to visit the National Space Centre, which is where our headquarters is, and met our space engineering students there. You can see in the bottom left-hand side, one of our students, Fahima, that was a picture that was taken for Pearson, who are the exam body for and the examiners for the BTEC qualification, and they wanted to highlight some of our students. You can also see some of our students like to try on different outfits by the looks of it. So you can see in the bottom right, 2 of our students doing work experience, and they're wearing the clean room gear that Angela was talking about earlier. So they had to put on the whole kit, even for their work experience. And we've got another work experience picture in the middle at the top as well on different projects. We try to support our students to get work experience opportunities and to go on visits to space sector sites. Obviously this year they haven't been able to go in person. And we find that 85%, around that amount, go on to study science subjects at higher education level. And they either go on to university or they go on to do something called a higher apprenticeship, which means that you're studying and you are earning at the same time. So apprenticeships are a really interesting pathway into the space sector, and most people who work in the space sector do have a degree, did take a university pathway, but it isn't the only way, as Angela was telling us earlier as well. We do have some students who go on to study completely different subjects at higher education level, and others who've gone straight into the workforce as well. What else do we do relating to careers? And I want to tell you about this because this will explain why I feel I know a bit about space careers and I can tell you a bit of advice about them. We run careers conferences. So we run these in person at the National Space Centre, which I mentioned a moment ago. It's where our headquarters is. And these photos are all from these in-person events. But we also ran an event just a week ago, a couple of weeks ago, called the Academy Takeover, where we took over the National Space Centre's YouTube channel. And you can see some pictures here in the middle of the videos that we recorded with Q&As with other people working in the space sector. So much like the people you've heard from today, we contacted people from different parts of the space sector working in very different areas and put questions from our audience, the public, and our space engineering students to them. And you can go back to the National Space Centre's YouTube channel and rewatch those. And all of these pictures, you can see people doing what Mario was talking about. They're talking to each other. The young people are asking questions of the different space professionals that we've brought to these events. And that's what people find really useful, is the chance to actually ask someone, what did you study? How did you know you wanted to do that? What did you do maybe if it all went wrong, which is another big question that we get. And we will keep running these events either online or in person. So if you do want to connect with the National Space Academy and keep an eye out for those events, you can do. Space sector is very broad and it incorporates lots of different things. So this is my way of trying to capture all the different things we can talk about in the space sector. And I say space sector because I mean the industry, the industrial side, and the academic side. And to me, that's a word that encapsulates that. And so you've got the exploration, studying the stars, astronomy, things like that. And it's great that we've heard today a little bit about how space applications can be useful for life on Earth. So that's what Catherine was talking about earlier with the tackling food waste problem. And then hearing about Mario's area of research, which takes some kind of space physics, but ties it back into understanding about our Earth. And Earth observation is a huge area of the space sector that I think is underrepresented, not known about so well. And also how we use space in our day-to-day lives. So I've included a satellite navigation image and a mobile phone image, because those are two things that we take for granted nowadays, walking around maybe with Google Maps on, that are actually reliant on space. So through talking to lots of different people across the sector, we have come up with our top 10 tips for finding a career in the space sector. And if you go to the National Space Academy website, you can find a link to a poster that has all of these tips on it that you can download and print yourself. I think I've given Vicky the link to pass on. That first one, talk to lots of people, is kind of what you're doing now in this event. And you can see a lot of the other topics have been raised by other speakers. So studying STEM subjects is perhaps the most direct way, considering things like apprenticeships, placements, looking at space competitions, going to space events. Learning another language might be a possible one, because it's a very international thing, which Mario was talking about with all the places he's been to. And that last one, be positive, find ways to be positive. And number 4, I think really important, follow your interests. Last thing I want to mention is National Space Academy's headquarters is the National Space Centre. It's closed at the moment due to coronavirus restrictions. We hope to be open in May, fingers crossed. When we are open, we're in Leicester. It's a visitor centre. You're welcome to come with your family. Schools visits very welcome as well. We have an education team who do workshops as well for younger children, and they also sometimes do careers events for younger children as well. This last screen's just got some information about how to get in touch with the National Space Academy, which I'm sure Vicky can pass on afterwards. So I will stop talking there and hand back to Vicky, and hopefully we'll get to hear some answers to some questions. And I've got the top tips in the background, just in case you want to see them later.
Wonderful. Thank you so much, Kiran. There was lots of useful information there. And as she mentioned, we will be sharing a poster of links, and there are some extra ones to add. So do keep thinking of questions and typing in the Q&A. I'm just going to quickly share what our poster looks like so you know what information is coming your way. So we'll be sharing some career profiles so you can find more people who work at RAL Space, what subjects they did at school or university. tips from the Space Academy and some videos, as Kieran mentioned. We've also got a video for an experiment, an activity that you can do at home to make your own space blankets. So the blankets that Angela makes, you can do a DIY version at home. So I'd suggest checking out that video. We've then got our online work experience for some of the older students, and work experience does run every year at STFC, so you can find out more information about that, as well as our other early careers. We have a video from an apprentice who recently did a placement with us, so you can find out what he actually did in his apprenticeship. And at the bottom, we've got some educational resources. So if you want to learn more about space, there are some free activity books for you to learn about the moon or meteorites and many more things. And more for any teachers as well, there are some teaching resources there if you want to really bring space into the classroom. So how to link space to your curriculum and the subjects that you are already doing in school. Finally, at the bottom are contact details, and probably most importantly, our Twitter handles as well. And I think we will post them in the chat a bit later on. So if you want to tweet us to tell us about today's event, feel free to do so. So as I mentioned, we will share that poster, so you don't need to remember all of this now. I will email it to you later on. Okay, so now let's get on to the Q&A. So I'd like to invite all our speakers back onto the screen, and you have got a few more minutes to think of some questions. We've got the last 10 minutes to do so. If everyone could quickly go around and say what GCSEs they did, what subjects did they do in school? Catherine, I'll go to you first.
Oh, I really have to think about that. I did sciences and French and history and maths and English and English literature.
Quite a variety there. Good.
Yeah.
Angela, what were your subjects in school?
My subjects were, we had a core set of subjects which were English language and English literature, maths, religion, and French. And then we chose 5 subjects, and I chose biology, chemistry, physics, Latin and geography.
So I'm definitely seeing a theme. Sciences and maths are very useful skills, but also the communication skills that Mario mentioned. So Mario, what were your GCSE subjects or equivalent?
So I did English language, English literacy, religious studies, business studies, maths, science, double science, music, and one other which escapes me right now.
Brilliant, thank you. Okay, I'm now going to come back to Catherine. Another question we had was, how long was your university course?
I spent 4 years at university because I did a master's degree. So it was the first 3 years of aerospace engineering, and then the 4th year where I specialised more into spacecraft engineering.
Excellent, thank you. And I think I will go around everyone again and ask you this question. Was it hard to get into your current job? Mario, what would you say?
I mean, it's always a lot of work. You have to work hard. You have to develop your career well. You have to build up to getting into positions that we're all in. So it really does, have that paving way of science from the start. Like I said during my talk, it really was my physics teacher that inspired me. He did his PhD at Rolls-Royce, and then when he semi-retired, he went into teaching, and I'm sure he inspired many others like me that then went off and did similar things.
So Angela, as you came into space a bit later on, it wasn't the first thing. When did you first become interested in space, and did you find it hard to get into this job?
Well, I was a very little girl when the man landed on the moon, very little girl. So there's always been that sort of mystery, if you like, about space. And I think working in space, I've got more and more interested in it and found more and more, areas that fascinate me. I don't think it was difficult to get into because like I applied for the job and I got the job. So it was a different route into RAL space. But yeah, the more I do it, the more I enjoy it and the more interesting it becomes.
Brilliant. And just sticking with you, Angela, we had another question. Why do we need to keep the clean rooms clean?
We need to keep the clean rooms clean because we don't want any dirt particles or basically anything that shouldn't be on the blankets, getting onto the blankets, because we don't want any anything to degrade the materials or, you know, cause any sort of short outs in the equipment once they get on there. And like I was saying, we are the dirtiest things in the clean room. So it's important that we keep ourselves well and truly covered up.
Oh, Mario, there was a good one for you, I think. So does space weather, is it as changeable as weather is on Earth? I think we all know that we see the weather predictions on the news and it's not always correct. So is space weather very changeable as well?
So space weather is changeable, but it's changeable on different timescales. So, you know, like you can be sat in your garden, beautiful sunshine, 10 minutes later, clouds come across, it can pour with rain. So with space weather, it's a little bit more slow in its action because it's such a vast distance between the sun and the earth. But it can change in the period of hours and sometimes days. And big parts of space weather might last for hours, days, or even sometimes a week. So yes, so it is changeable. There's a lot of variation, a lot of different effects, but it doesn't change quite as quickly as you do when you sat in your garden.
Excellent. Okay, over to you, Catherine. The courses that you attended and all the other things that you did they help you get into your job today? Did they help you in when you applied for your job?
Yeah, first off, they really helped me understand that I wanted to work in the space industry and to inspire me more about the different areas of the space industry that I didn't know about before. And as well as that, they gave me things to talk about in interviews and experience that I could bring to interviews, which was really useful in helping to understand some of the questions I was being asked and prove my interest and prove that I was the person they wanted to hire. So yeah, I'd say so.
That's great. And yeah, definitely good to be able to help you actually decide what you wanted to do. That's excellent. Okay, let's see what else. So, I think I will ask this for you, Angela. How many projects have you worked on? How many different templates have you used for MLI? Can you give a ballpark figure?
Oh gosh, I think the largest project we've worked on was 117 blankets for one satellite. But it's that varied. I've been here 4 years and I must have worked on about maybe 12 different projects. And sometimes it'll be 5 projects in 1 week. So you've got to be sort of, you know, quite adaptable and quite, able to change your work patterns.
Okay, so let's go back to thinking about subjects again at school. So do you all feel you got good grades at GCSE, or did that not matter as much in helping with your future careers? So I'll go to you, Catherine, first.
Say I did relatively well. Feels like I'm selling myself, but yeah, no, I didn't do too badly at GCSE, and that did help me to go down the path of A levels and go through the university path into engineering. But as people have said, that's not the only way. So if you're not someone who's getting perfect grades, then maybe an apprenticeship route is more suited to you, or maybe there's other paths into the space industry. So I'm not sure it's the be all and end all.
And Mario as well, what would you say? Did you did lots of courses and then you went on to do a PhD, but do you think grades are a big part of that? Or actually, would you agree with Catherine that it's not always the biggest important thing?
I agree with Catherine that there's lots of different pathways, but for my personal pathway, it was grades that got me to each step. So to get to A levels, it was the grades at GCSE. I had 3 A stars, 3 A's and 4 B's. To get to university, it was my A level grades, where I got A, 2 B's and a B in AS music. And then from university to get to the PhD, it was the undergraduate degree, and then so on and so forth. It was good PhD performance then that got me into my first postdoc. So
how many years did that take in total then? So from your subjects in school right until you got the job at ralspacee, how many years?
2 years for GCSE, 2 years for A level, 4 years for undergraduate, and almost 4 years for PhD. So that will take you up to 12 years. Yeah.
Okay, quite a long time. But again, that's just one route, and an apprenticeship, for example, can be a much shorter route into the space industry. Angela, I'd like to ask you, did anyone inspire you to join the space industry? Can you think of anyone in particular? Or was it the astronauts who first landed on the moon?
Yeah, I think that was the thing that first sort of tickled my interest. Who inspired me? I think it's for me, it's somebody that's not even anything to do with space, and that's my mum and dad, who taught me to work hard and to go for what I wanted and to be passionate about things, and that if I was all those things, then you get to where you want to go.
Excellent. I think that is a brilliant answer. I think everyone's nodding along there and agreeing that actually role models don't have to be the scientists or engineers, but the people around us as well, maybe your teachers at school. So I have one more question for everyone. Let's try and keep a short answer as we've just got a minute left. What's your favourite thing about working in space? Catherine, you go first.
It's collaborations, working with a big team of people with different interests, all of whom want to get a great spacecraft at the end of it.
Mario, what's your favourite thing?
I can't agree more. It's working with all the great people, not just locally at RAL, but all around the world. Yeah.
Yeah. And Kieran as well. I'd want to hear from you. What's your favourite thing, Kieran, about being in the space industry?
Yeah, I agree with what Catherine and Mario have said. And it's also, it's being part of something bigger. And that's what inspires a lot of young people as well, either the exploration of space or what we can do here on Earth with space technology. It's bigger than us, and that feels important and exciting.
And Angela, very quickly.
Yeah, I agree with everything everybody said. And for me, it's the way that everything comes together. You've got one bit comes together, another bit comes together, and the whole makes the thing that goes into space. It's just not one little bit, it's the whole thing, which everybody puts together, and it's a great bunch of people.
Thank you very much. I think that's all really good points. I hope you've all found this webinar interesting today. I have just launched a poll, so we're interested to see if your opinion has changed. So after watching this webinar, do you agree that space is for everyone? And would you like to work in the space industry? Hopefully you've seen that there is a huge variety of jobs and different skills, people with different backgrounds that all work together to make space missions and projects successful as well. So I will give you a moment to answer those. And we will also, we'd also really like your feedback as well. So if you'd like to tell us how this event was, you could tweet us. And there is also a short survey that you will find at the end of this webinar when you click leave. And I will email the link to the survey as well. So I think that's all from us. Thank you very much for filling in those poll questions. The final thing for me to say is thank you very much to all of our speakers, to Kieran from the Space Academy, to Mario, Catherine and Angela, for sharing all their experience and insights being part of the space industry. And hopefully you've seen that there might be something for everybody. So that's all from us. Thank you very much for joining today. I hope you have enjoyed it, and I hope you enjoyed the rest of British Science Week. Goodbye, everyone.